Hello boys and girls, welcome to the first session of Codingame. A colleague of mine a co-worker has told me that this is actually a game where you are encouraged to code. Some enemies are attacking you in this spacey fighting arena. And depending on how well you code the task that is given to you, the better you score in this game. So let's take a look at it. It could be fun. This game, Codingame lets you improve your coding skills with games. It starts in the IDE, where you will code and test new ideas. This is your mission statement. Solo and multiplayer coding games are turn-based. If it's turn-based, why did I lose? I let it run unattended for a couple of minutes and it seems that the attack by the enemy is over and I lost. Solo and multiplayer coding is turn-based. At each turn your program gets new inputs and must output the action. Right. Yeah, I have read this task. So your program must destroy the enemy ships by shooting at the closest enemy on each turn. So for that you have to, within the game loop, obtain information of the two closest enemies. Before your turn is over, output the value of either enemy 1 or enemy 2 to shoot the closest enemy. Okay. Choose a programming language. Well, I am familiar with Python 3, so let's go with Python 3. So isn't there a thing? Let's tell your program to shoot the closest alien. Okay, so how? While one is basically wrong, we can do better. It's called while true. Enemy 1 is what? Input 1. What the hell is input? I don't care what these enemies are called. Write an action using print. Shoot the color. Okay, using print. Okay, so we can basically print shoot. I'll probably need something like shoot and then enemy and enter the code here. What? I don't understand this. It looks like we've got I mean, game information. Zap has been targeted. So what is this? Which one is the enemy? Is this me? Is this the enemy? I don't know who am I and who is the enemy. Looks like I thought this would be me, but So you were destroyed, you were hit by charger, so Zap has been targeted. Threats within range is a charger and hard hat. What the hell is that? Distance. Enemy 1. Ah! What? Achievement unlock. What's this button? I don't understand anything what's going on. I mean, this is so confusing. Maybe do C++. Yeah, let's first understand what they want. If I can't understand it in Python, I will certainly not understand it in C++. I'm all in for C++, but do you know what to do with the code? I mean, do you understand the code they've given you? It's absolutely nonsensical. Here is the game you code just played. Something went wrong. Try again. Okay. Oops, your code didn't pass the test. Well, this code, I don't even know what to write. Edit your code. Game loop. Threats within range. Rock 70. So enemy input. Name of the enemy is probably rock. And integer, I don't know. Integer enemy 1 is 70 meters. Enemy 2, there is no enemy 2. Can be a quote. And now we actually can define a function. Closest enemy, which will get enemy 1 and enemy 2, right? And that's actually called def. With def we define a function in, and I mean, we would need I need a class. I like a class enemy. Class which would get name and distance. Closest enemy. Okay, so now this function gets 2 enemies, and I'd have if enemy 1 distance is less than enemy 2 distance, return enemy 1, else return enemy 2, right? So I define an object which is an enemy. It has a name, it has a distance, a function which compares the distances of two enemies and returns the one with the lower distance. And then enemy 1, distance 1 is this. And I will say I defined an enemy 1 as an instance of the class enemy, which gets the name of enemy 1 and the distance of enemy 1. Well, the problem is that I have only one enemy. I have nobody to compare it with. And I'll shoot enemy 1. Name. I mean, it's so I don't really need this comparison function right now, but well, this is actually bad code. What they tell me, compare the distances. How do I know that the distance 1 is truly related to enemy 1? Nothing but the variable name tells it. This is... Got it. Let's check your code. Yeah, let's try this. Something went wrong. Okay, what went wrong? Copy paste the code it shows. I mean, isn't it stupid? That's a stupid code, isn't it? I mean, how can we assume that distance 1 is related in any way to enemy 1? This is just... Okay, but let's go with their bad practices. And enter the code here. Okay, got it. I got no information. I got no information about two enemies. Your code did not pass the test. Of course, why should it? I mean, I don't know. Enter your code or click the blah 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 and copy paste the given block into the proper place. Ooh, game loop. Yeah, got it. So what? Try again. Yeah, how can it compare to enemies if it's got only one enemy? Maybe I was maybe I need something like, maybe I need those stupid inputs, like enemy 1 equals input distant 1 equals what? Integer of input, and copy paste that to 2. This is totally bullshit. Whatever. this is bad code. How can they reward it 100%? Right, what next? Oh boy. I am 5+ year of professional. What is XP? What do you expect? Other. I expect to see how if this game really teaches good coding practices. Do I have to add my nickname? Ah! So what now? Oh. It was off. What next? Learn, contribute, practice. Loops. Ah, here we have loops, here we have lists. Okay, let's do loops. So what now? Solving this puzzle makes you learn and understand the concept of loops and the ways of retrieving the maximum value from a list of integers. Well, there's a library for that, you know. This puzzle can be a playground to experiment the concept of lambdas. Yeah. Sorting. Okay, let's solve it. So what? Destroy the mountains before your starship collides with one of them. For that, shoot the highest mountain on your path. At the start of each game turn, you are given the height of the 8 mountains from left to right. I don't see any mountains, but let's assume there are some. At the end of the game turn, you must fire the highest mountain by outputting its index from 0 to 7. Sounds easy. Firing on a mountain will destroy part of it, reducing its height. Your ship descends after each pass. You win if you destroy every mountain. You lose if your ship crashes into a mountain or you provide incorrect output. Note: don't forget to run the tests by launching them from the test cases window. Oh, this is good. Actually, I like this. This is a good practice. You should always have some software tests when coding. Within an infinite loop, infinite loops are evil. I don't know why they even teach them. There are so little circumstances where you really need an infinite loop. So few circumstances. Within an infinite loop, read the heights of the mountains from the standard input and print to the standard output the index of the mountain to shoot. Oh, whiskey. No, I wish it would be whiskey, but it's just some sherry schnapps with some other schnapps mixed. Hello, Linus. One integer. So standard input and print to the standard output the index of the mountain to shoot. Input for one game turn, 8 lines, 1 integer per line. Okay. Can we? Ooh, yeah. Okay. 1 integer mountain age per line. Each represents the height of the mountain given in the order. output. In range 8, so now I see some discrepancies here. One integer per line. Each represents the height of one mountain given their index from 0 to 7. Okay, so they can be stored in a list, I guess, because list has indexes. And constraints, what does it mean? 0 is greater or less than mountain height, and that's less than 9. Response time per turn is less than 100 milliseconds. A single line with one integer for the index of which mountain to shoot. Right. Okay, so let's say while true, for I in range 8, you are given the height of, this represents the height of a mountain. So is there a mountain with height 0, 1, 2, 3, 4, 5, 6, 7? Always? Is there each turn with mountains of this height? So that all heights from 0 to 7 are represented in there? I would like to know the heights of these 8 mountains. I mean, it could be something like 5, 5, 3, 2, 8, 1, 6, and so on. So, how am I supposed to know these mountain heights? Represents the height of one mountain. Write an action using prints. The while loop represents the game. Each iteration represents one turn of the game, where you are given inputs, the heights of the mountains. Okay, each turn I'm given some inputs. Okay, so let's make a list of mountain heights. Is an empty list. For I in range 8, for each mountain I'm given an input. And list actually append this. Right, so I append integer 0 through 7 in the list. So I have 0 on index 0, 1 on index 1, or whatever height they say. But if they say, I mean, this is ridiculous, isn't it? So if this input. Okay, if this gives me the height of the mountain. Okay, let's presume this gives me a list of the mountain. So I will append it to the list. Actually, append is bad. I have absolutely no idea what to do here. In what form am I? Okay, let's assume I have mountain height and I want maybe I must prepare a list of 8 slots. List of 8 slots. Goodness. I don't even know how to prepare a list of 8 slots because it's so unPythony. But this is clearly not how you do it. What's the null or nothing expression in Python? Nothing? If I don't want to give it a value, if I don't want to initialize the list with a value, I can give it a nothing, null. What is this? Nil? No, what's the keyword in Python? I think it's null, but I don't know. None! It's none! That's it. Okay, so I guess we'll make a list of 8 nones. It's so stupid to prepare such lists. I'm supposed to append 8 times 8 things, so something like there is a zip function. Python dict zip Python zip function, which could help me zip iterables. Yeah. Range. If X and no, that's not what I need zip for. There's another such function which would be more elegant to use. Range, certainly, range is an iterator. Start, stop, step. I guess it should be lambda then. Lambda. Zip takes an iterator for one in iterables. Was also there was a box function, bool. I don't even know how you prepare a list of 8 slots, because I've never used it. I've been programming in Python for so many years. I've never really needed to have a list or an array of a given length. Never, ever. It always happened to be the bad coding practice. And they are kind of forcing me into it here. Because I will be given 8 inputs. And if the list is of length 0, then I cannot obviously. I need a list of length 8. Okay, let's have a list, and then for x in range 8. Let's do this stupid thing they want. List append none. Okay. Now I have a list of 8 nones. Good. Wonderful. Are you happy, program? For I in range 8, mount 8, it will get an input and list of this on the index of I will be assigned the value of mountain height. Okay, now we've got it. Right. We could have made it much more elegant. But they really... I don't know what will happen if I get rid of their stupid list. Or if they're stupid. Okay. Now we have the math library. So we can prepare a helper variable. Something like index of highest mountain equals none. Right. And then if we look at Python function, there's a function max. There it is. Iterable key and default. Right. So that's basically easy. we say after this is filled with mountain heights, we say index of highest mountain is the max of the list of mountain heights. And max returns the maximal value, which means we actually need a key argument specify the one argument ordering function. Okay, return the largest item in an iterable of the largest of iterable of the largest of two or more arguments. If one positional argument is provided, it should be an iterable. I don't even need the index, right? I can return. Oh, they are forcing such un-Pythony coding practices on this. That's not how it's done in Python. It's just not how it's done. If I want just the index, if I have to return the index. So yeah, actually I know how it's done. So here I will get the maximum height, and then I will have to search or get the index of, is there an index, something like, there's a function get the index. String index, list index method index. Okay, that's it. Index method. This method returns the index of the found object. Otherwise, raise an exception indicates that the value wasn't found. Okay, so so max will return the maximum, return the largest item. And then after I've got this largest item, I have to dive into the list again and look for it. It's so stupid. So maximum value, and I need again a list of highest mountains, index, and give me the index of the highest. Right. And I don't even need to store it in an extra variable, and just print the index of the highest mountain. Okay, and this is so crazy what they force you to do, but I think that this will be okay. So test cases. So we prepare our index of highest mountain. We don't even need this variable here. We have a list of mountain heights, which is at the beginning of each turn filled with nothing, 8 times nothing. Then we fill it with these inputs, and then we look at, oh yeah, actually, yeah, that's true. We get an input for a mountain, and at the index we place the mountain. Okay, it's so stupid. It's not how we would do it in Python, but okay. Read action using print. the index of the mountain to fire on. So first we find the highest mountain, and then we will look for the highest mountain in the list and return the index of it, because they want an index. Okay, whatever. I think that's it. So let's play the test case of descending mountains. Okay. Descending mountains. Mountain 0, mountain 1, mountain 2. Invalid syntax. Answer pi not in a function on line 13. What? Of course, of course. You are completely right. Yeah. And this is, of course, this. Try again. At answer pi not in a function. What the hell do you want? Oh, of course, this doesn't have to be here. Okay, we got it. So first mountain, we got a 0 and so on and so on and so on. Yeah. Yeah. 5 of 9. That's it. This would go, this would go, this would go. You're clear for landing. Okay, scattered mountains. Okay, let's try scattered mountains. I mean, what do we care? It finds the highest. It shoots the highest. Yeah. Clear for landing. Okay, strong mountains. Okay, let's have some mountains with. There hasn't been a case where a height of the mountain has been repeated. It will become interesting when there are two highest mountains, like two mountains would have the height of 8 or 9 or whatever. Okay, strong mountains. Test this. Okay. Cleared for landing, and one mountain only. Congratulations, you passed all tests. Of course I did. It took me quite a while to get there, but we can submit this thing. Computing score 100%. Here we go. Keep coding. Reach 100%, reach 100%. Okay, click to rate. Well, I didn't like it. Okay, what next? Improve your coding skills with the following puzzle. Coders strike back or join a 5-minute coding battle. No, I'm a slow coder. Coders strike back. Okay, what does it mean? What do you even want? What will I learn? Optimization, multi-agent, neural network. Oh, that would be fun to learn. Distances, trigonometry. You must submit your code. Okay, I can probably practice some more. Ah, here we go. Power of Thor. Puzzle easy. Let's try some medium puzzle. There is no spoon. Intervals, binary search. Oh boy, oh boy. Lists. Pathfinding, labyrinth. Conditions. Arrays, loops, and conditions. Conditions. Plus 50, plus 75, plus 100. 20% completed. Best suggestions, conditions. Okay. Let's get Thor. This puzzle, you will need to compare different values. Didn't we have that already? 8 conditions. Way to simplify to use only 4 conditions. Okay, solve it. Basic problem. Whatever. So, what does it mean? Your program must allow Thor to reach the light of power. Thor moves on a map which is 40 by 18. Note that the coordinates x and y start at the top left. So there is 0 to 40 and 0 to 18. This means that the top left cell is 0, 0 and the most bottom cell is 39, 17. Once the program starts, you are given the variable light x and light y, the x and y coordinates of the light of power that Thor must reach, and the variable initial Thor x and Thor y starting position of Thor. At the end of the game turn, you must output the direction in which you want Thor to go. Among north, northeast, east, south, southwest. Okay, okay. Each movement makes Thor move one cell in the chosen direction. You win when Thor reaches the light of power. Okay. Initial phase. Thor starts at 3.6, light is at 3.8, action south, moves south. New position is 3.7, south again, 3.8, win! Good. The program must first read the initialization data from the standard input, then in an infinite loop provides on the standard output the instructions to move Thor. Integers indicate the position of the light, integers indicate initial position of Thor. Input for a game round. The number of remaining moves for Thor to reach the light of power is remaining turns. You can ignore this data, but you must read it. Good. A single line is the output. Output must be a single line providing the move to be made. Print SE. Okay, okay. Okay. Constraints. Blah, blah, blah. Time for one game round. Okay. Well, this seems simple enough. I mean, I can go with this. Auto-generated code below aims at helping you pass the standard input according to the problem statement. Light x, light y equals a list of integer I for I in input split. the hell is this? That's some syntactic sugar I don't understand. Integer of I. So return a list of integers of i's. Put split, I guess. Yeah, that's a good thing. Yeah, that's fine. We can live with this. So we have light x, light y, initial tx, initial ty. That's good. We have the coordinates here. You can use the debug stream to print if the source seems to not to follow you. Okay, while true. Remaining turns. Do not remove this line. Write an action using print. Okay, obviously we will have to calculate which way to go. I guess we'll have to calculate the difference between where the light is and where Thor is. We'll need a difference vector. And there are 4 possibilities. There is a light, there is Thor. If we make it easy and simple, we'll have initial position of Thor somewhere here and light somewhere here, so the difference will be positive and positive. So we'll define a function Okay, let's have a dictionary. How to move. Run as a dictionary of positive dict zip. Zip will zip these. It will have positive and positive. Then it can have positive and negative. Then it can have, I don't know whether I'm doing the right thing. Negative and positive and negative and negative. And if the difference between light and Thor is positive and positive, he should move to northwest. If it's positive into the x direction but negative in the you should move southwest, I believe. Y direction, southwest. If it's so, this was true. This will be false. So this will be some east and east. And it will be northeast and southeast. But what about if they are equal? If the difference is 0. This is not a good dictionary then. Okay, I see we need a dictionary of 6 or 8 cases rather than just north, south, southwest, and east. Too complicated. I have actually more important things to do than this. So it could be that the difference is greater than 0, 0, or less than 0 for each coordinate. Yeah, that's basically how to move in x direction. Okay, let's make a dictionary of how to move in x direction, which can be either less, equal, or now maybe the dictionary is not the best thing here. Maybe the dictionary is not the best way to solve this. Something like if diff, maybe let's have a function def move in X depends on difference. It will get doesn't even need to light and Thor. If the difference between the light, so it will be given a light coordinate, light x coordinate is this, so maybe light is here, very high, Thor is very low. It will make the difference if light minus Thor is greater than 0, then it will move to the difference between light and Thor, it will move to the east. Else or elif light minus Thor is lower than 0, it will return west, and if neither of those two is true, then it will return empty string. Okay, and we will print move of light x and initial Thor x plus move okay, and we need x no we need move move x and x if x return e else return. If we are not moving in the x direction but in y direction, so if light y is bigger than Thor y, the difference between light and Thor will be positive, so in this case we will need to move south. If we are moving in x direction, light is here, Thor is here, and the difference is not, so light is here, Thor is here. The difference between light and Thor is less than 0. We're about to move in x direction, so the x direction need to be west. But if we are not moving in x direction, we need to return. If we are moving in a y direction, and the light is here and Thor is here, and we subtract Thor from light, we'll get a negative number. Thor is here, light is here, Thor is here. We will have to move north. And if it's nothing, then we return nothing. So if true, remaining turns is this, move light x, initial Thor x, and we are moving in x direction, yes, or so that is true. And plus move light y coordinate, initial ty coordinate, and we are not moving in one direction. I think this is it. I think this is it. So let's play all test cases and see. Unexpected end of file. Indeed it is. Unexpected end of file, really? How come? Of course, we are missing a bracket. Good, good, good. Try again. Name move is not defined. Is it not? Ah, good. Moving in x direction is not defined. Why is it not? Ah, of course, x moving in direction is not defined, yeah. Yeah. Ha! It returned WS. It's supposed to return SW rather than WS. Ah, yes. Mm-hmm. Yeah, that's true. Isn't this stupid? It is. Oh, goodness. So I don't see a very elegant way to do this. Let's make a dictionary. It will save it. Dict. Zip. List. List. So we will have north. Oh, dict zip north, south, east, west, northeast, east north, northwest, west north, southeast, east south, northeast, east north, northwest, west north, southeast, east south, southwest, west south, and list. North will map to north, south will map to south, this will map to northeast, this will map to northwest, this will map to southeast, this will map to southwest. Dict zip list and input correction input correction of this correction of it's a dictionary. I think now it should work. I'm pretty sure you can just swap the calls to move so that y comes first. Really? Why should y come first? Then it will crash the other way. Why would you say that if I calculate the difference in y coordinate first? You say if I do the y coordinate first? No. You mean so if I say if not moving in y, no, the problem is that I have either south or east. If I have the y direction here, moving in y direction, then I would basically get first either north or west, and then east or south. I don't... Look at the possible moves. Y direction comes before x. Northeast, southeast, and so on. Okay. It's interesting. Let me think about it. So you say if I... So what should be the Yeah, but then I would still need two functions, right? I would need functions for give me the direction in y direction and then give me the direction in x direction. And I want it's kind of one function doing both, just switching by this parameter. Okay, so let's try it. There is light and there is Thor. And if we call this, we are moving in y direction. Okay, so basically we need to switch the conditions, right? So we'll have first, so if we are moving in y direction, is that what you mean? Then we calculate light minus Thor, and if we are moving in y direction, so if we are calculating, so y direction is this. Light is here, Thor is here. We make the difference of both. Light minus Thor is still greater than 0, so Thor needs to move to the south. Return south. Else it will return north, obviously. Actually, only if light minus Thor is lower than 0, it will return north. If it's neither the case, it will return nothing. And if we are not moving in y direction, then if we are not moving in y direction, means we are moving in x direction. So Thor is here, light is here. We build the difference between light and Thor. Thor here, light here. Thor here, light here. Difference between light and Thor is still positive. Thor here, light here. Thor needs to move into... Thor is here, light is here. Thor needs to move east. And if the difference between light and Thor is lower than 0, so light is here, Thor is here. Light minus Thor is less than 0. Thor needs to move in this direction, so it needs to move west. Okay. So if we are moving in y direction, okay. Moving in y direction. So we don't need the correction dictionary, it seems. So moving, we are giving it the light and Thor coordinates, and first we calculate the x direction, so we are not moving in y direction, that means false, and we are giving it true. Okay, well let's try it. This looks interesting. Okay, what does it mean? Takes at most one argument and 12 given. Okay, that's very easy. Oh, you just delete the why would you? Okay. Okay, no, that's not good. Okay, so let's play all test cases. Okay, this is going good. So it found WS. It's not working. Not working like this. It doesn't work like this. Oh boy, this is bad. This shouldn't be here, should it? That's why it behaves badly. Yeah, it still returned WS. So Thor position 31.4, light position 0.17. And it returned WS even if we are doing this. I know. Let's forget about it. I'll use my correction. I don't know. I don't even want to debug this, because yeah, it's an obvious weakness of this thing. You could probably correct it somehow, but dict zip list. Why does it want? It has two lists. Dict zip. I thought zip would do exactly what it does. Given two iterables like this, zip xy, it'll do this. And that's not what we need to make a dictionary. Actually, it is. A list takes at most one argument. No. Okay, list takes at most one argument. Okay. You got it. And then I really don't need these as lists. I don't need to cast them to lists. Okay, play all test cases. Thor wandered off the path and died. Interesting. Why would he do that? Of course, because this is a false direction. I need to switch it back as I had it. Again, it found WS. What the hell? Of course, I didn't put the correction back there. Correction of this. Ha! Ah, of course, remaining turns, and we need we need to update the the coordinates then. Ah, we need to update the coordinates after each turn. So after we have moved to one direction, we then need to update those coordinates. This is too complicated. I would have to save somewhere the difference and let's program something useful. I don't. Well, yeah, it's nice gamey programming, okay, but this is good for games programming. I don't think this kind of programming will encounter you much unless you are a game developer. I have a harder part of programming, a WebSocket today, so I'll take a short break, get a new drink, and we will take a look at programming WebSockets in what is it called? The superb language processing. Yeah, I mean, this is I would have to think about this very much, but I can't really get invested into these problems too much. But they are good. They are good. But I don't like the format of having some turn. Oh, okay, who knows this? Yeah, I'll see you soon.